Scientists have been exploring the evolution of our universe for decades, trying to understand better the cosmic phenomenon exhibited by the celestial bodies that occupy space. They found planets in all shapes and sizes, from minor dwarf planets to massive gaseous planets. Some share similarities, but many have unique characteristics that set them apart. Today we'll find out about some of the most bizarre, terrifying planets discovered by scientists in space. In recent years, the rush of exoplanet discoveries has changed our ideas about what a planet can be. An exoplanet is a planet outside of our solar system that usually orbits a star other than our Sun in our galaxy. Scientists recently discovered the hottest planet with a surface temperature greater than some stars. As the hunt for planets outside our own solar system continues, we have discovered many other worlds with extreme features, and the ongoing exploration of our solar system has revealed some weird contenders too. The hottest, HD 195689. How hot a planet gets depends primarily on how close it is to its host star, and how hot that star burns. Mercury is the closest planet to the Sun in our own solar system, at a mean distance of 57,910,000 kilometers. Temperatures on its day side reach about 430 degrees Celsius, while the Sun itself has a surface temperature of 5,500 degrees Celsius. But stars more massive than the Sun burn hotter. The star HD 195689, also known as Celt 9, is 2.5 times more massive than the Sun and has a surface temperature of almost 10,000 degrees Celsius. Its planet Celt 9b is much closer to its host star than Mercury is to the Sun. Though we cannot measure the exact distance from afar, it circles its host star every 1.5 days. Mercury's orbit takes 88 days. This results in a whopping 4,300 degrees Celsius, hotter than many stars with a lower mass than our Sun. The rocky planet Mercury would be a molten droplet of lava at this temperature. Celt 9b, however, is a Jupiter-type gas giant. It is shriveling away as the molecules in its atmosphere break down to their constituent atoms and burn off. The coldest, Ogle 2005 BLG 390Lb, the temperature of just 50 degrees above absolute zero, negative 223 degrees Celsius. Ogle 2005 BLG 390Lb snatches the title of the coldest planet. At about 5.5 times the Earth's mass, it is likely to be a rocky planet too, though not too distant from its host star at an orbit that would put it somewhere between Mars and Jupiter in our solar system. Its host star is a low-mass, cool star known as red dwarf. The planet is popularly referred to as Hoth, in reference to the icy planet in the Star Wars franchise. Contrary to its fictional counterpart, however, it won't be able to sustain much of an atmosphere, nor life for that matter. This is because most of its gases will be frozen solid, adding to the snow on the surface. The biggest, planet Dennis P. J082303 1-491201b. If a planet can be as hot as a star, what makes the difference between stars and planets? Stars are so much more massive than planets that they are ignited by fusion processes as a result of the huge gravitational forces in their cores. Common stars like our Sun burn by fusing hydrogen into helium, but there is a form of star called a brown dwarf, which is big enough to start some fusion processes, but not large enough to sustain them. Planet Dennis P. J082303 1-49120b, with the equally unpronounceable alias 2-mass J082303 13-4912012b, has 28.5 times the mass of Jupiter, making it the most massive planet listed in NASA's exoplanet archive. It is so massive that it is debated whether it is still a planet. It would be a Jupiter-class gas giant, or whether it should actually be classified as a brown dwarf star. Ironically, its host star is a confirmed brown dwarf itself, the smallest Kepler 37b. Just slightly larger than our Moon and smaller than Mercury, Kepler 37b is the smallest exoplanet yet discovered. It is a rocky world closer to its host star than Mercury is to the Sun. That means the planet is too hot to support liquid water, and hence life on its surface. The oldest, PSR B1620-26b. PSR B1620-26b, at 12.7 billion years, is the oldest known planet. A gas giant 2.5 times the mass of Jupiter, it has been seemingly around forever. Our universe at 13.8 billion years is only a billion years older. PSR B1620-26b has two host stars rotating around each other, and it has outseen the lives of both. These are a neutron star and a white dwarf, which are what is left when a star has burned all its fuel and exploded in a supernova. However, it formed so early in the universe's history, it probably doesn't have enough of the heavy elements, such as carbon and oxygen, which form later, needed for life to evolve. The youngest, V830 Tauri, our planet system V830 Tauri, is only 2 million years old. The host star has the same mass as our Sun, but twice the radius, which means it has not fully contracted into its final shape yet. The planet, a gas giant with 3/4 the mass of Jupiter, is likewise probably still growing. That means it is acquiring more mass by frequently colliding with other planetary bodies, like asteroids in its path, making it an unsafe place to be. The worst weather, Venus. Because exoplanets are too far away for us to be able to observe any weather patterns, we have to turn our eyes back to our solar system. If you have seen the giant swirling hurricanes photographed by the Juno spacecraft flying over Jupiter's poles, the largest planet in our solar system is certainly a good contender. However, the title goes to Venus. A planet the same size of Earth is shrouded in sulfuric acid clouds. The atmosphere moves around the planet much faster than the planet rotates, with winds reaching hurricane speeds of 360 kilometers per hour. Double-eyed cyclones are sustained above each pole. Its atmosphere is almost 100 times denser than Earth's, and made up of over 95% carbon dioxide. The resulting greenhouse effect creates hellish temperatures of at least 462 degrees Celsius on the surface, which is actually hotter than Mercury. Though bone-dry and hostile to life, the heat may explain why Venus has fewer volcanoes than Earth. NASA says newly discovered weird planet with unknown atmosphere is remarkably similar to Earth. Recently discovered a new weird planet has excited scientists to hunt for extraterrestrial life. Researchers from NASA's Jet Propulsion Laboratory and the University of New Mexico discovered exoplanet TOI 1231b orbiting an M-dwarf star, otherwise known as a red dwarf. Scientists were able to characterize that star and measure the radius and the mass of TOI 1231b. This then gave them the necessary data to calculate density and hypothesize what the atmosphere is made of. The planet, a temperate sub-Neptune-sized body with a 24-day orbit, is 8 times closer to its star than Earth is to the Sun, but its temperature is similar to our home planet because the red dwarf itself is less potent. Its atmosphere is approximately 330 Kelvin, or 140 degrees Fahrenheit, making TOI 1231b one of the coolest small exoplanets accessible for atmospheric studies discovered yet. It is possible that there may be clouds present high in the atmosphere and possibly evidence of water. The low density of TOI 1231b indicates that it is surrounded by a substantial atmosphere rather than being a rocky planet, but the exposition and extension of this planet are unknown. TOI 1231b could have large hydrogen or hydrogen-helium atmosphere, or a denser water vapor atmosphere, which would point to a different origin, allowing astronomers to understand whether and how planets form differently around M-dwarfs compared to the other planets around our Sun. The team assigned to the project searched for dips in the brightness of X-rays from X-ray bright binaries, which usually contain a neutron star when a massive star collapses, or a black hole pulling in gas from a closely orbiting star. The material near the neutron star or black hole becomes superheated and glows in X-rays. The region creating bright X-rays is small, so a planet passing in front of it would be easy to spot, as it would block most X-rays. This allows exoplanets to be detected at much greater distances. However, researchers will have to wait a long time to confirm whether they have discovered an extragalactic exoplanet. Due to its large orbit, the planet candidate would not cross before the binary partner for another 70 years, meaning it could take decades to confirm the observation. Now that you've watched the video, let us know what you think in the comment section below. Thanks!